Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more thermodynamical quantity connected to the ensemble. According to your CSIR June 2011, whenever the CSIR people will started multiple choice question paper from descriptive to multiple choice, this is the first question paper. So that is in that time they are asking this question. Once you have to see, consider a system of n non-interacting spins of each as a classical magnetic moment of magnitude mu. So what is that? So that is a classical magnetic moment of magnitude. So that system is a classical system. Clear? First you have to take it as a, based on that sentence, we have to observe that system is a classical system. Consider a system of n non-interacting spins, each of which has a classical magnetic moment of magnitude mu. The Hamiltonian of the system of energy in external magnetic field H is equal to, this Hamiltonian is equal to minus summation I is equal to 1 to n, I is equal to 1 to n mu I dot h, where mu I is the magnetic moment of ith spin. We need to calculate magnetization per spin. How many interacting particles are there? N number of interacting particles are there. We need to calculate the magnetization for spin is equal to how much we need to calculate. So magnetization for spin is equal to how much? How we able to calculate? Once you have to see the magnetization of spin value have to calculate. First we need to calculate the energy. So the Hamiltonian is nothing but will act as a energy. E is equal to mu dot h minus mu dot h. So therefore E is equal to minus mu dot, you have to remove. So mu h cos theta, this is the energy value we calculated. For a classical oscillator, we need to take it as a ensemble. So what is the classical oscillator ensemble? For a single particle ensemble is equal to z is equal to, that partition function is equal to, the partition function is equal to e to the power of minus beta into e. We have to write it is in terms of theta. So that's we able to take it as a sin theta d theta d phi. You have to write it is. So now you substituted there, z is equal to integral e to the power of minus beta minus into minus plus beta mu h cos theta, beta mu h cos theta into sin theta d theta d phi. You have to write it is. So but you know that you have to take this integral, two integrals are there, integral 0 to 5 e to the power of beta mu h cos theta, e to the power of beta mu h cos theta sin theta d theta into integral 0 to 25 into d phi. You have to write. So integral d phi is equal to 5. So that is going to get it as a 2 phi. So therefore your partition function is equal to, z is equal to what we have to write it is 2 phi into integral 0 to 5 e to the power of beta mu h cos theta into sin theta into d theta we have to write. So let there is a direct integration is not there. So that's why you have to take so let cos theta is equal to x you have to consider. So you have to differentiate explicitly minus sin theta d theta is equal to dx. Now you have to change the limits. So what are the limits are there? Theta is equal to 0. If theta is equal to 0, so what will happen? Cos 0 is equal to 1. So if theta is equal to, you have to take it as a 5. So cos phi is equal to minus 1. So therefore what we have to write? So based on that you have to take it as a z is equal to 2 phi into integral minus 1 to plus 1 e to the power of beta mu h x. So mu h x into which one we have to write, it is dx. So we have to change the minus symbol. So minus 1 to plus 1, that integration also changes. So therefore we have to write it is z is equal to 2 into, so we have to get it the integration e to the power of ax is equal to e to the power of ax is divided by a beta mu h into x is divided by beta mu h, you have to write it is, which is equal to minus 1 to plus 1 you are going to take. So therefore z is equal to 2 into is divided by beta mu h, you have to write it is, so e to the power of beta mu h into 1 minus e to the power of minus beta mu h, you have to write it is, you have to rearrange, you have to multiply with 2 and divided with 2. So what will happen, you able to take 2 into 2 phi, your partition function z is equal to 2 into 2 phi, 4 phi is divided by beta mu h, 4 phi is divided by beta mu h, e to the power of mu beta mu h minus e to the power of beta mu h is equal to, is divided by 2 sin h beta mu h, you have to write. This is the partition function for a single particle. Which particle you have to take? For a single particle you are going to get it, this is the partition function. For n number of particles, for n non-interacting particles are there, for n particles non-interacting spin moments are there. So therefore for n number of particles, that partition function is equal to, this is the z1. So what is your partition function? 4 phi is divided by beta mu h into sin h of beta mu h whole to the power of n. This is the partition function. So after calculating this partition function, our ultimate goal is to calculate the magnetization for spin, we need to calculate. So for that what we have to do, so the second one you able to take it as a Helmholtz free energy. What is the formula for the Helmholtz free energy? Is equal to minus kT into ln z, F is equal to minus kT into ln, your z is equal to, what is your z? 4 phi is divided by beta mu h into sin, we have to write it as a h of beta mu h whole to the power of, we have to write it as a n. So therefore what is your Helmholtz free energy? N is equal to minus n kT into ln, we have to write it is 4 phi is divided by beta mu h, so into, we have to write it as a sin h of beta mu h, you have to write. This is your Helmholtz free energy. So after calculating this Helmholtz free energy value, so we need to calculate the magnetization. The magnetization formula, what is the magnetization? M is equal to minus dou F is divided by dou H. This is the magnetization formula. Now you have to substitute there minus dou by dou H of your F, you have to substitute. So what is your F? N kT ln. So n kT, you have to write it as minus n kT, correct? So minus n kT ln, you have to write it as 4 phi is divided by beta mu h, 4 phi is divided by beta mu h into sin h of beta mu h, sin h of beta mu h. This is your F value, have to substitute it. Clear? So now you are going to differentiate. So what with respect to h, you have to differentiate. Here there is no h is there, minus into minus, plus it will come. So therefore n kT you are going to get it. N kT into, so ln, so this is entire thing you have to take first x. So therefore 1 by 4 phi is divided by beta mu h into sin h, sin h into beta mu h, you have to write it, sin h of beta mu h. Again you have to take this one, you have to consider as a u, and this one you have to consider as a v. What is going to write it is, once you have to take here 4 phi is divided by, first u dash I am writing, minus 4 phi is divided by beta mu h square you are going to get. Again same you have to write it as sin h of beta mu h, you have to write it. So now plus, so 4 phi is divided by beta mu h, you have to take, you have to differentiate v sin h, you have to differentiate, you are going to get it as a cos h. So you have to take it as a cos h beta mu h, cos h beta mu h. Again you have to differentiate beta mu h, you are going to get it as a beta mu, you are going to get it. So now you have to multiply this term to this, and this term to this term you have to multiply, you are going to write it is, how we are going to take, once you have to see your magnetization m is equal to, what we have to write, you able to take it as minus n kT into 4 phi is divided by 4 phi is divided by beta mu h, 4 phi is divided by beta mu h sin h of beta mu h. So again you have to multiply this sin h of beta mu h. So sin h of beta mu h, so beta mu h is divided by beta mu h square is there. This is the first term. Now the second term you have to take. So what is the second term? So plus nkt into nkt is divided by 4 phi is divided by beta mu h, 4 phi is divided by beta mu h into sin h of beta mu h, sin h of beta mu h into, so we have to write it is cos h of beta mu h into beta mu, you have to write. So now is there any cancelling terms are there? You have to cancel it. 4 phi you have to cancel. Sin h beta mu h, sin h beta mu h you have to cancel. 1 beta, 1 beta, 1 mu, 1 mu, 1 h get cancelled. So therefore minus n kT is divided by beta is there. Here also you have to substitute here. So beta, what we have to do here? So you are going to take it as a 4 phi also is there, you have to multiply there. So one more term is there, I am missing here. 4 phi is divided by beta mu h, you have to take. This 4 phi is divided by beta mu h, this 4 phi is divided by beta mu h, 4 phi is divided by beta mu h, cos h by sin h is equal to cot h. So your kt is equal to 1 by beta, so 1 by beta get cancelled. So therefore you have to write it is, what is the term is remaining, that term you have to write m is equal to in the first denominator minus n kT is divided by h is remaining, minus n kT is divided by h. So minus n kT is divided by h, you have to write it is, so your beta is equal to 1 by kT. In the second term, so what is you are going to take it as a second term, so which one you have to write it is, cos by sin is equal to tan, here n into mu, what is there, your n into mu into cot, so h, cot h into beta mu h, you are going to get it. So now you have to rearrange this. So minus n into mu is divided by mu h, so that is the 1 by kT is equal to beta n into mu into, what we have to write it is, cot h beta mu h, you are going to write it is this, which is equal to, that is the magnetization. So now what we need to get, the magnetization per spin of the dipole is equal to, we have to write it is mu, you are able to take the common. So what is going to write it is, this is cot h of beta mu h minus 1 by beta mu h, you have to write it is. This is very, very simple. So m by n is equal to, that is the average magnetization is equal to that mu into, so we have to write it as a Langevin function of beta mu h, also we have to write it. Is clear? So this is your answer. What is the Langevin function? You know that the Langevin function L of x is equal to cot h of x minus 1 by x. This is the Langevin function. Clear? So like this you have to do. So what is your answer? According to your option you have to check it, mu into cot h of beta mu h minus 1 by beta mu h is there. So your answer, once you have to check your answer will appear. So mu square h by kt is not correct. Mu into cot h beta mu h minus 1 by beta mu h, because kt is equal to 1 by beta, so that is the beta it will come. So here beta it will come, you have to take that. So you have to cut it, you are going to get which option is correct. Option B is correct. So like this you have to do in your competitive examination. So in every video I am informing you, we started the CSIR and GATE physics content coaching. So you are listening so many videos I am uploading you. So based on canvassing purpose I am uploading you. So theory I am not teaching in the YouTube channel. Theory I have to teach in our our app only. If you are really interested to get the CSIR or GATE or JL or DL or SET, any examination, if you want to take our course, you have to download our app. After downloading our app, you able to call me. So 9908437460, this is my mobile number. So you have to negotiate me. After downloading our app, our courses will display like this: CSIR and GATE physics content, JL physics content, DL physics content. So not only that, individual courses also available. Right now we finished these first 4 papers: mathematical methods of physics, classical mechanics, electromagnetic theory, quantum mechanics we are finishing. Now we are under the thermodynamics and statistical mechanics. This thermodynamic part almost we finished. So we are teaching now statistical physics part we are teaching. So every day morning 6 a.m. to 8 a.m. in between 6 a.m. to 8 a.m. there is a live class. That live class belongs to the statistical physics only. Every day evening 7 p.m. to 8 p.m. in between the 7 p.m. to 8 p.m. so there is a live class. That live class also belongs to the statistical physics only. So if statistical physics will finish, more than 60% of the syllabus we are covering. So if these 5 papers you have to read, any competitive exam you can crack. Clear? So that's why the rest of the papers also I will do that one. So already Telangana SET 2025 notification came. So you concentrate on this. Thank you so much. Please share and like and subscribe our YouTube channel. You have to inform to your friends also. Thank you.